Welcome back to another video, and in this video we're going to be continuing on with our core data tutorial series, and in this particular tutorial we are going to be taking a look at how we can set up core data in a SwiftUI application. Now, there are, as with core data in AppKit, a few ways that you can set this up. You can leave the original way that that core data is set up in a SwiftUI application by Xcode. Excuse me. Or you can use a separate approach that uses a data controller observable object for core data operations. I'm gonna show you both and kind of explain to you why you might want to use one approach over the other. All right, so let's go ahead and open up Xcode. Inside of Xcode, we're going to create a new project. All right. So inside of Xcode here, we're going to select the multi-platform platform here. And then under template chooser, we're going to say app. We're going to say tutorial app SwiftUI core data. And then we are going to set the testing system to none. And then we're going to use core data for storage. And then the host in CloudKit checkbox should remain not checked because we're not going to do CloudKit in this series again, like I've mentioned previously. So go ahead and hit next. After we get our file chooser dialog, select a place where you want to save your project, and then I'm going to hit create. And here is Xcode. Now I'm going to make sure that our Xcode takes up the entire screen here. We're going to fill. There we go. Now, the first thing that I want to bring your attention to is inside of our navigator here, inside of our project navigator, we are going to have a file called persistence.swift. When we look inside of this file, you can see we have a few different things. So let's go through it. I am going to get rid of this comment up here because it is irrelevant. Here we have a struct called persistence controller. And then inside of this struct, we have a static let shared. So this persistence controller is what we call a singleton. If you're unfamiliar with the singleton design pattern, I urge you to read up on that design pattern. Sean Allen on YouTube has a good explainer video about singletons, especially in the context of iOS development. So I urge you to take a look at that video. Now we have a preview property that is also static. And what this does is it pretty much creates some test data based on an item entity that it creates in your core data model for you. And it's marked as main actor because it wants to make sure, right? We want to make sure that this code will only run on the main thread. And this is a Swift concurrency thing. It's not exactly too important right now what main actor means. You just need to know that when something is annotated with main actor like this, that in layman's terms means that it's constricted to running on the main thread. So I'm actually going to remove this constant because we're not going to be using the previews. You can keep it if you want, and if you're going to use this approach, again, you can keep it if you want. I'm not going to because I don't use the previews. Now, you can see here that based on its syntax, the preview constant is a lazy constant, so this stuff will only be loaded when it's required. So I'm going to get rid of that. So we have a little bit more room here on screen and it looks nicer. So the next thing that we have is a declaration for an NS persistent container object, but we're not initializing it yet. Excuse me, guys, I am so sorry. Our NS persistent container is called container. Now, we have an initializer for our persistence controller. This initializer takes in a Boolean determining whether or not our persistent stores should be in memory, meaning every time the application closes, the memory gets flushed, and therefore all the data we've saved also gets flushed. This kind of thing using an in-memory database is useful, especially in tests, like when you're unit testing or integration testing. Having an in-memory database helps to make sure that everything is exactly as it was in your last test run when you start a new test. Now, inside of this initializer, we are creating we're initializing our NS persistent container. And we're giving it a name. Again, this name, much like I pointed out in the last two videos, is the name of the core data model file that core data will use to generate our underlying SQLite persistence store. I'm going to put a blank line there to make it look a little bit nicer. Here, we're testing to see if in memory is true. And if it is, we're specifying that the location of our persistent store should be /dev/null. And what that basically says is, hey, this should be in memory, right? You should store this in memory, and when the application closes, it should be flushed along with all the other memory. And so, otherwise, it'll be loaded in the default location that an application would generate the SQLite database in, as defined by the persistent container. Then we're loading our persistent stores using the load persistent stores method of our NS persistent container, which takes a completion handler. This completion handler takes two parameters. It takes a store description or NS store description object, which is an object meant to describe essentially the persistent store, and then an optional error. Now, it's not optional to provide this, but the type is an optional type of error, any error, because because this could fail. Now, the reasons why load persistent stores could fail are a few. There's a few different reasons, but among them could be maybe your iOS device, your your Mac, whatever, doesn't have enough storage. Maybe the parent directory that the persistent store is supposed to be in doesn't exist anymore. Maybe you don't have write privileges, stuff like that could cause it to fail. So if it does fail for any number of those reasons, error will not be nil. But if everything goes A-OK, then it will be nil. Now, inside of the completion handler, what we're doing is we are basically saying, hey, is this error nil? And then we're casting it to an optional NS error. Right? So we're saying if let error equals whatever error we get back in the completion handler as an NS error, an optional NS error. Now, why is NS error being used here? Well, the reason for that is because core data is almost 20 years old. When it was created, we didn't have Swift. We had Objective-C. So we didn't have the Swift error type that we do now. We had NS error. So NS error is used by core data, and that's why we have to use NS error here. We have to use some Objective-C parts of the API in order to work with core data. It's not pleasant, but it is necessary. All right, now inside of this if let statement, if there is an error, we call fatal error, essentially causing our app to crash, and then we're giving it some information about the error. Now, here's the thing, right? In a real world application, you aren't going to want to use fatal error. In a production app, in a real world app, you're going to want to convey to the user that something went wrong. Now, using fatal error is useful for development, but of course you shouldn't use it in a shipping production app. And now I'm also going to get rid of these comments here. There we go. And then here we're configuring our managed object context. So here we have container.viewContext. Now, viewContext is the property of our NS persistent container where we get our NS managed object context that we're going to be working with. Now, automatically merges changes from parent. If we go ahead and jump to the definition of this property, here we can see that this is available on specific platforms. But pretty much what this is going to do is this is going to basically tell the managed object context to merge any changes from its parent context, because there can be multiple managed object contexts, and if you have multiple contexts and each of them have their own set of unsaved changes that they're tracking, we want to be able to merge them all together. And that's what this property is doing, pretty much. All right. And that's it. That is our persistence controller. Now, if we go into our main abstract, we can see how we're using this. Okay. So again, I'm going to get rid of these comments because they're not exactly relevant. Here we have our @main attribute. We have our app struct that's conforming to the app protocol. Here we are defining a constant called persistence controller, and it's going to be equal to that shared instance of persistence controller that we specified as a singleton. Then inside of our body here, we have our window group, scene, and we have our content view. But what we're doing is onto our content view, we are using the environment modifier to set the current value for the managed object context environment value to the view context property of the container property of our persistence controller. All right. And so that is, that's how our persistence controller is used, right? We are using it to set up core data and then to inject the managed object context into the environment for us to use in our applications. And then, of course, they have some basic code for us to work with. But we're not going to look at that just yet because there are things being used there that we haven't covered yet. Like being able to delete things from core data, being able to add things to core data, and being able to fetch stuff from core data. All of that stuff will be covered in upcoming videos, but for now, we're not going to worry about that too much. All right. Now, the other way that I use to set up core data, depending on what kind of project I'm doing, is we can create a data controller that is an observable object. And so let's go ahead, and I'm going to show this to you just so you have an idea of another way to do this. Go ahead and create a new file. And I'm going to say Swift file. And I'm going to call it data controller. And inside of this file here, I'm again going to get rid of the comments. And then I'm going to add an import for core data. And then we're going to create a class called data controller. And then we're going to have this conform to observable object. Perfect. And then in here, what we're going to do is we are going to create a lazy variable called container. So we'll say lazy var container, set it equal to ns persistent container equals like that. And then inside of here, we'll say let container equals ns persistent container with a name of tutorial app SwiftUI core data. And then we'll say container dot load persistent stores. And because this completion handler is the only parameter here in the method call, I can make this a trailing closure instead, where we can have a store description. So the ns persistent store description object, and then we'll need an error. Inside of here, we'll say if let error equals error as ns error with a question mark, because it needs to be optional. Now, one thing you also may have noticed that I didn't point out is that when we're converting that to an optional ns error, we don't have any question mark or exclamation point combined with the as keyword. And the reason for that is because the error type in Swift is directly bridged to the ns error type of Objective-C, so we can use as in that way, unlike many other types. All right, so inside of this if let, we'll say fatal error unresolved error error dot user info, just like that. And then we will return container. All right. And so now we have our lazy variable here. I'm going to also define a save method. So we can say func save, where we can say if container dot view context dot has changes. We can say do try container dot view context dot save with a catch, and we'll say fatal error unresolved error and then we'll say error dot localized description. We could also do something like this where we have let error equals error as an NS error. We can say, instead of localized description, user info, to be a little bit more in line with everything else. And with that, we can then go back to the abstract for our application. And we can comment out our persistence controller. And we can have an @state object, private var data controller equals data controller, like that. And then we can still inject the managed object context into the environment, but instead of using the persistence controller, I'm going to comment out this version of the modifier. And we'll say dot environment / dot managed object context. We can pass it data controller dot container dot view context, and then we need to pass this view as into the environment, like the data controller itself, using environment object. So dot environment object, and then pass it data controller, like that. And so there we go. We can go ahead and save our code and try to run it. And we do have a build failure. So let's go ahead and take a look at what we may have done wrong. Right, so here we do have one issue, and that is with the preview. So, okay, I need to... Alright, we're gonna... There we go, we can reopen that. What we're going to do here is we're gonna go into our content view. I know I said we weren't gonna go in here, but we kinda have to in order to fix the issue we're having. At the very bottom, we have a hashtag preview thing here, and we need to pretty much get rid of all of this, like that. There we go. Save it. Now we can run it, and we have a successful build. let it load, do its thing. It tries to run on my iPhone here, but I'm going to change the run destination to the Mac. Say my Mac. And we have a successful build even on the Mac, which is good. So far, so good. Let it do its thing. And here we go. So here you can see our application. It's simply a navigation split view with a list. We can go to our toolbar here. And we can add a couple items by hitting this button. And you can see here, we now get a bunch of items added to core data in accordance with the template that we got. We close it and we run it again. You can see everything got persisted. We just switched from using our persistence controller to a separate observable object class instead. And this is useful for a few reasons. If you need a central place, for example, to manage other data pertaining to your core data stuff, like selected items in a sidebar or something like that, then you could do that in that class as well as have all your core data stuff in there. Paul Hudson on Hacking with Swift Plus in his Ultimate Portfolio app demonstrates that really well. So if you are subscribed to that, you can check that out, but again, you have to pay for it. But this is just another approach you could take if you want to do something other than what Apple gives you, which most of the time what Apple gives you is fine. But this approach does allow you to be a little bit more flexible. Alright, so that pretty much does it for this video, guys. Thank you all so very much for watching, and we'll see you in the next video.